August 17, 1943. 27,000 feet above Schweinfurt, Germany, 11:42 a.m. Hauptmann Wilhelm Fischer of Jagdgeschwader 26 rolled his F-190 into attack position, his practiced eyes measuring the closure rate with the formation of American bombers climbing toward the ball-bearing factories below. The veteran ace with 43 kills smiled behind his oxygen mask as he studied the massive four-engine aircraft struggling to maintain formation despite flak damage. The Americans had sent their flying fortresses deep into the Reich without fighter escort, exactly as the Luftwaffe had hoped. Like shooting cattle in a barn, Fischer transmitted to his wingmen, echoing the contempt that had become standard among German pilots when discussing the B-17. The Boeing bomber was large, slow, and, German intelligence assured them, poorly defended. Its defensive armament looked impressive on paper, but suffered from coverage gaps that experienced fighter pilots could exploit ruthlessly. More importantly, the Americans flew in rigid formations that limited evasive maneuvers, making deflection shooting almost absurdly simple. Fischer rolled inverted and pulled through into his attack dive, positioning for a head-on pass that would take him through the bomber's nose where only two 50-caliber machine guns could bear. His 20mm cannons and 13mm machine guns were already armed, his gun sight centered on the lead bomber's cockpit. The attack would last 3 seconds. At his closing speed of nearly 500 miles per hour, 3 seconds would give the American gunners minimal time to track him, minimal time to fire, minimal time to react. What Fischer didn't know, what German intelligence had failed to fully comprehend, was that he was diving toward the most heavily armed bomber ever built, defended by 13 50-caliber M2 Browning machine guns that could collectively put 6,000 rounds per minute into the air. He didn't know that American gunners had trained for months specifically to counter head-on attacks. He didn't know that the Boeing B-17G model, which had entered service just months earlier, had added a twin-gun chin turret specifically to address the nose vulnerability he intended to exploit. Most critically, he didn't know that the seemingly scattered formation was actually a carefully designed combat box that created overlapping fields of fire, transforming individual bombers into mutually supporting gun platforms. What looked like confused tactical organization was actually a killing zone, where any attacking fighter would face fire from dozens of heavy machine guns simultaneously. Fischer pressed his attack, confidence absolute. The German pilots had been shooting down B-17s for nearly a year. They knew the bomber's weaknesses, understood its limitations, and respected its toughness without fearing it. The Flying Fortress was exactly what its name suggested, a defensive weapon that could absorb punishment but posed limited offensive threat to an experienced fighter pilot. The transformation from contempt to terror would begin in the next 5 seconds. By the time Fischer's Focke-Wulf 190 passed through the bomber formation, 3 German fighters would be burning fragments falling toward the German countryside they were defending. Fischer himself would survive only because his aircraft disintegrated so quickly he was thrown clear before the fuel tanks exploded. He would spend the remainder of the war with a shattered spine, living testimony to what happened when German assumptions met American engineering. The story of how the B-17 Flying Fortress evolved from object of derision to instrument of annihilation is the story of how American industrial capacity, systematic design philosophy, and operational doctrine combined to break the Luftwaffe's back. It's the story of how a bomber initially dismissed as inadequate became the weapon that destroyed Nazi Germany's ability to wage war. And it begins not with combat, but with a design philosophy that prioritized crew survival and mission completion over every other consideration. The Boeing Model 299, which would become the B-17, first flew on July 28, 1935, at Boeing Field in Seattle. The prototype crashed during Army Air Corps evaluation trials when test pilots failed to disengage the control locks, pilot error that nearly killed the entire program. That the Army ordered the aircraft despite this disaster speaks to how revolutionary the design was considered. The bomber that emerged from Boeing's Seattle plant was unlike anything previously conceived. 4 Wright 1820 Cyclone engines, each producing 1,200 horsepower, hung from wings spanning 103 feet. The aircraft weighed 32,000 pounds empty and could carry 4,800 pounds of bombs to targets 2,000 miles away. More significantly, it bristled with 5.30 caliber machine guns in positions covering most approach angles, hence the name Flying Fortress, coined by a reporter at the prototype's unveiling. The pre-war B-17 was impressive by 1935 standards, but would have been slaughtered in 1943 combat. The defensive armament was inadequate, armor protection was minimal, and the operational doctrine assumed bombers could fight their way to targets without escort. The transformation from this vulnerable prototype to the combat-proven B-17G that terrorized German fighter pilots required 4 years of combat experience, thousands of design modifications, and technological innovations that rewrote bomber design philosophy. The early combat experience of B-17s with the British Royal Air Force in 1941 was catastrophic. The RAF received 20 B-17Cs under Lend-Lease and attempted daylight precision bombing missions over occupied Europe. German fighters destroyed or damaged aircraft at unsustainable rates. The British concluded the B-17 was inadequate for combat and relegated surviving aircraft to coastal patrol duties. American observers drew different conclusions. The problem wasn't the aircraft design, but the tactical employment and specific vulnerabilities that could be addressed through modification. The B-17C's defensive armament had significant gaps. The aircraft lacked adequate armor protection. The bomb load was insufficient for the risks involved, but the fundamental airframe had demonstrated remarkable ability to absorb damage and return crews safely. This resilience would become the B-17's defining characteristic. German pilots would spend years learning that the Flying Fortress was almost impossible to kill with anything less than overwhelming fire. The aircraft could sustain damage that would destroy other bombers and continue flying. More importantly, it could keep flying with sufficient control to allow the crew to bail out over friendly territory or reach emergency landing fields. The B-17E, entering service in September 1941, represented the first comprehensive combat modification. The defensive armament increased to 9.50 caliber machine guns in powered turrets and handheld positions. The tail gun position gained a dedicated gunner instead of being manned by the radio operator during attacks. The ventral ball turret, perhaps the most iconic feature, provided 360-degree lower hemisphere coverage that previous models lacked. The ball turret deserves particular attention because it epitomized American design philosophy. The Sperry A2 turret was a technological marvel, a 1,000-pound sphere containing 2.50 caliber guns, a computing gun sight, and a gunner, all suspended below the bomber's fuselage. The gunner sat in a cramped fetal position, his head between his knees, controlling the turret's rotation and elevation through electric motors while tracking targets through a reflector sight. German pilots quickly learned to fear the ball turret. The gunner had unobstructed view of the lower hemisphere and could engage fighters attacking from below or behind with devastating accuracy. The installation was so effective that it became standard on all subsequent B-17 variants and was copied by other American bomber designs. The ball turret gunner position was perhaps the most dangerous assignment in the most dangerous job in the American military, but it transformed the B-17 from a defensively vulnerable bomber into a genuine aerial fortress. The B-17F, entering service in April 1942, featured numerous improvements based on early combat reports. The plexiglass nose was strengthened, additional armor protected critical systems, and engine reliability increased through systematic modifications. The bomb load capacity increased to 8,000 pounds for short-range missions. Most significantly, production ramped up dramatically as Boeing, Douglas, and Lockheed Wega factories began mass-producing airframes. The industrial achievement represented by B-17 production remains staggering even by modern standards. At peak production, American factories completed one B-17 every 60 minutes around the clock. The Boeing plant in Seattle employed 30,000 workers operating 3 shifts. The Douglas plant in Long Beach, California, built B-17s in facilities that had been empty land 18 months earlier. Lockheed Vega's Burbank factory, primarily known for fighters, was retooled for bomber production in months. Each B-17 required 400,000 individual parts, 36,000 rivets, 12 miles of electrical wiring, and 1,200 pounds of aluminum. The engines alone contained 11,000 individual components machined to tolerances of thousandths of an inch. The propellers, manufactured by Hamilton Standard or Curtiss Electric, were complex variable pitch mechanisms that required precision manufacturing. The turbo-superchargers, enabling high-altitude operations, were technological marvels that pushed metallurgical capabilities to their limits. Yet American workers, many of them women who had never seen an aircraft before Pearl Harbor, assembled these complex machines with precision exceeding peacetime standards. The Rosie the Riveter phenomenon wasn't propaganda, it was industrial reality. Women comprised over 40% of Boeing's workforce by 1943, performing tasks that required considerable skill and generated production quality that consistently exceeded Army Air Force's specifications. The quality control was obsessive. Each aircraft underwent comprehensive testing before acceptance. Engines were run up and tested at full power. Every system was checked, every control tested, every gun fired. Test pilots flew each aircraft through demanding evaluations that would have been considered combat-level stress in previous wars. Aircraft that failed any test were sent back for correction, no matter how minor the deficiency. This commitment to quality meant American bombers arrived in combat theaters with reliability German industry couldn't match. While Luftwaffe units struggled with maintenance problems and parts shortages, American bomb groups operated aircraft that functioned with remarkable consistency. The joke among American crews was that the biggest danger was falling parts from aircraft above, not mechanical failure. But it was the B-17G, entering service in September 1943, that would transform the bomber into the weapon German pilots learned to dread. The most visible change was the addition of the chin turret, 2 .50 caliber guns in a remotely controlled Bendix turret beneath the nose. This installation eliminated the frontal vulnerability that German pilots had been exploiting since 1942. Now, head-on attacks meant flying into concentrated fire from 4 guns, 2 in the chin turret and 2 in the nose compartment. The B-17G's defensive armament totaled 13 .50 caliber machine guns, 2 in the chin turret, 2 in the nose, 2 in the dorsal turret, 2 in the ball turret, 2 in the waist positions, 1 in the radio room, and 2 in the tail. These weapons could collectively fire 6,000 rounds per minute, 100 rounds per second, each projectile capable of penetrating armor, igniting fuel, or severing control cables. The .50 caliber M2 Browning machine gun deserves recognition as perhaps the most successful aircraft weapon ever designed. Developed by John Browning in the 1920s, the M2 fired a 1.7-ounce projectile at 2,900 feet per second with effective range exceeding 1,000 yards. The ammunition, manufactured to incredibly tight tolerances, fed through electric or hydraulic mechanisms with remarkable reliability. Stoppages were rare. When they occurred, trained gunners could clear them in seconds. The ammunition itself was carefully designed. The standard combat load mixed armor-piercing, incendiary, and tracer rounds in patterns optimized for different targets. Armor-piercing rounds could penetrate the armor protection of German fighters at typical engagement ranges. Incendiary rounds contained magnesium powder that ignited on impact, often starting fires in fuel systems or hydraulic lines. Tracer rounds allowed gunners to observe their fire and adjust aim, while providing visual deterrent to attacking fighters. The psychological impact of massed .50 caliber fire cannot be overstated. German pilots described attacking B-17 formations as flying into a wall of glowing tracers, knowing that for every visible tracer, there were 4 invisible rounds. The distinctive sound, a rapid hammering that shook airframes, was recognizable from hundreds of yards away. Fighters caught in concentrated fire often disintegrated instantly, literally torn apart by the kinetic energy of dozens of heavy projectiles striking simultaneously. The tactical employment of B-17s exploited this defensive firepower through the combat box formation. This three-dimensional arrangement, developed through painful trial and error in 1942-43, positioned bombers so that their defensive fire overlapped, creating zones where attacking fighters would face fire from multiple aircraft simultaneously. A fighter attacking one bomber would be exposed to gunners on 5 or 6 other aircraft, each with clear shots. The combat box was not a simple formation. It consisted of multiple elements stacked vertically and staggered horizontally, with precise spacing that maximized defensive coverage while minimizing collision risk. Lead elements flew slightly higher, with trailing elements stepped down. Aircraft were offset laterally so that no bomber was directly behind another, eliminating blind spots. The result was a formation that looked chaotic, but was actually a precisely engineered killing zone. German pilots attacking these formations described the experience with terms suggesting trauma. Hauptmann Heinz Knoke, a Luftwaffe ace who survived the war with 33 victories, wrote, "Attacking the American combat boxes is like assaulting a medieval fortress. Every approach is covered by fire. You cannot attack from any angle without exposing yourself to multiple guns. And their gunners are not afraid. They fire constantly, filling the sky with tracers. Many times I have broken off attacks simply because continuing meant certain death." The effectiveness of this defensive system is demonstrated by gunnery claims versus actual losses. American gunners claimed destroying approximately 6,000 German aircraft during the war. Post-war analysis confirmed about 2,600 actual German losses to bomber defensive fire, still a remarkable achievement. The discrepancy reflects the difficulty of confirming kills in combat with multiple gunners firing at the same target, but also indicates that defensive fire was deterring attacks rather than always destroying attackers. Fighters that broke off attacks due to defensive fire survived to be engaged again, but the bombers they had abandoned were able to continue their missions. The deterrent effect was significant. Luftwaffe tactical directives from 1943 onwards increasingly emphasized attacking damaged or straggling bombers isolated from formation protection. Attacking tight formations was discouraged except when overwhelming numerical superiority could be achieved. This represented a fundamental shift in German doctrine, from aggressive interception to opportunistic targeting, driven primarily by respect for B-17 defensive firepower. The aircraft's structural resilience reinforced this defensive firepower. The B-17 was designed with redundancy throughout. Multiple control systems meant that damage to one wouldn't necessarily compromise control. The wing structure used multiple spars, so that damage to one spar wouldn't cause catastrophic failure. The fuselage was divided into sections with separate pressurization and heating, so damage to one section didn't doom the entire crew. The stories of B-17s returning from combat with catastrophic damage became legendary and weren't propaganda exaggerations. Aircraft returned with entire sections of wings missing, tail surfaces shot away, engines destroyed, and fuselages perforated with hundreds of holes. The bomber nicknamed All-American returned from a mission over Tunisia with a MEV 109 having collided with it mid-air, nearly severing the rear fuselage. The aircraft landed successfully. Another, Old Faithful, completed missions despite having been hit by anti-aircraft fire over 250 times. The Memphis Belle, perhaps the most famous B-17, completed 25 missions over heavily defended targets and returned to the United States for a publicity tour. The aircraft had accumulated significant damage over those missions. Hundreds of flak holes, cannon shell impacts, and damage from fighter attacks. Yet it brought its crew home every time. The Memphis Belle became the symbol of the B-17's resilience and the courage of its crews. That courage was tested constantly. Being a B-17 crew member was statistically among the most dangerous jobs in the American military. The 8th Air Force, operating B-17s from England against targets deep in Germany, suffered approximately 26,000 killed in action, 18,000 wounded, and 28,000 taken prisoner. This from a force that never exceeded 200,000 personnel. A crew member's chance of completing the required 25 missions was approximately 25% in 1943, meaning 3 out of 4 crew members could expect to be killed, wounded, or captured before completing their tour. These losses occurred despite the B-17's defensive capabilities and structural resilience. The bomber was tough, but it wasn't invincible. German fighters armed with 30mm cannons could destroy a B-17 with a single well-placed hit. Flak batteries firing 88mm shells could shred an aircraft with one burst. The mission profiles required flying through the most heavily defended airspace in history, straight and level during bomb runs, at altitudes where temperatures reached 60 degrees below zero and oxygen was so thin that minor leaks in masks could cause fatal hypoxia. The physical environment itself was a deadly enemy. At 25,000 feet, the temperature regularly dropped to -40 or -50 degrees Fahrenheit. Crew members wore electrically heated flight suits, but failures were common. Frostbite was a constant threat. Gunners particularly suffered from exposure while manning waist guns in openings exposed to -50-degree slipstreams. Fingers froze to metal gun grips. Exposed skin froze to metal surfaces in seconds. Many crew members finished missions with frostbitten fingers, toes, and faces that required amputation. The psychological stress was equally severe. Missions lasted 8 to 10 hours, much of it spent in constant vigilance against fighter attack while enduring flak bursts that shook the aircraft and sent shrapnel tearing through thin aluminum skin. Crew members watched other bombers explode, break apart, or fall burning from formation, knowing they might be next. The noise was constant and overwhelming, engines roaring, wind screaming through openings, guns firing and flak bursting. Communication was difficult even with intercom systems. Crew members often returned deaf for hours after missions. Yet they continued flying. Day after day, crews climbed into their B-17s and flew into some of the most heavily defended airspace ever created. They flew through fighter attacks that killed crews in aircraft flying 50 feet away. They flew through flak so intense it turned the sky black with explosive bursts. They flew knowing the statistical odds were against survival, yet maintained formation discipline and completed missions with professionalism that impressed even their enemies. The German pilots who faced these formations daily developed complex feelings about their adversaries. They respected the courage required to fly mission after mission despite appalling losses. They admired the B-17's toughness and the American gunners' skill. But they also feared what the bombers represented: unlimited American industrial capacity delivering sustained attacks that German defenses couldn't stop. Oberst Johannes Steinhoff, a Luftwaffe ace with 176 victories, none against American heavy bombers, captured this sentiment in post-war interviews. "We could shoot them down. We did shoot them down, but more kept coming, always more. They absorbed losses that would have destroyed any other air force and returned the next day in equal numbers. The B-17s didn't defeat us in individual combat, they defeated us through sheer persistence. They kept coming until we ran out of fighters, out of fuel, out of pilots, out of everything. That was the true terror of the American bomber." The battle for air superiority over Germany in 1943-1944 was fought primarily by these bombers and their escort fighters. The strategic bombing campaign remains controversial. Historians debate whether the resources invested justified the results achieved. But the impact on the Luftwaffe is indisputable. German fighter production increased throughout 1943-1944, yet operational strength declined. German pilot training suffered as experienced instructors were pulled to frontline units to counter bomber streams. Fuel production became a critical bottleneck as refineries were targeted relentlessly. The missions themselves followed brutal routines. Crews were awakened at 0200 or 0300 for briefings revealing the day's target. The reactions varied. Some targets were considered milk runs with lighter defenses, while others like Schweinfurt, Regensburg, or Berlin meant facing maximum enemy resistance. Crews ate breakfast knowing that some of them wouldn't return for dinner. They collected their equipment, heated flight suits, parachutes, oxygen masks, helmets, gloves, and personal weapons in case they were shot down. The pre-flight walk-around inspections were thorough despite the darkness and cold. Pilots checked control surfaces, examined engines for leaks, tested props. Engineers verified fuel loads, checked oil quantities, examined hydraulic systems. Gunners loaded ammunition, 3,000 to 4,000 rounds per gun, each belt carefully prepared with the correct mix of ammunition types. Bombardiers loaded bombs and armed fuses. Radio operators checked communication equipment. Everything had to be perfect because there would be no chance to return for forgotten items. The engine start was a ritual. The Wright R1820 Cyclone engines, 1,200 horsepower radials, required careful starting procedures. The inertial starters wound up with a distinctive rising whine before the engine caught with belches of smoke and noise. Each engine was run up individually with the flight engineer monitoring temperatures, pressures, and magneto performance. Only when all four engines were running satisfactorily could the aircraft taxi. The takeoff itself required skill. The B-17 weighed 65,000 pounds fully loaded, more than most fighters weighed empty. The takeoff roll consumed most of the runway. The aircraft lifted off slowly, gaining altitude grudgingly. Formation assembly took an hour or more as individual aircraft joined their squadrons, squadrons joined groups, and groups joined the bomber stream that could extend for dozens of miles. The climb to combat altitude took another hour, with the bombers spiraling upward in formation, engines straining to push the heavy aircraft to 25,000 or 28,000 feet. At altitude, crew members went on oxygen, tested their guns with short bursts, and began the endless vigilance that would continue until landing. The bombardier assembled and fused the bombs. The navigator calculated wind corrections and adjusted the flight plan. The pilot and co-pilot managed power settings to maintain formation position. The engineer monitored systems continuously. The gunners searched the sky for fighters. The moment when enemy territory was crossed was marked by flak bursts, black puffs of smoke appearing suddenly as 88mm anti-aircraft shells detonated at preset altitudes. The flak was terrifyingly accurate when German radar controlled the batteries, with shells bursting precisely at bomber altitude. The formations would fly through flak fields that shook the aircraft and sent shrapnel tearing through aluminum skin. The sound of shrapnel hitting the aircraft was unmistakable, metallic rattles and bangs as fragments perforated metal. Crew members could only wait and hope nothing critical was hit. The fighter attacks usually began after the flak ceased, although sometimes German fighters would attack through their own flak if they were desperate enough. The gunners would call out approaching fighters over the intercom, "Fighters, 12 o'clock high," or "Bogies at 9 o'clock level." The aircraft commander would alert the crew, "Gunners, we've got company, watch your sectors." The fighter attacks came in multiple forms. Early in the war, German pilots preferred approach from behind and below, where the B-17's ventral coverage was weakest. The installation of the ball turret largely ended this approach. German pilots then shifted to head-on attacks, diving from altitude to flash through the formation at combined closure speeds exceeding 500 miles per hour. The B-17G's chin turret was developed specifically to counter this tactic. By 1944, German pilots were using increasingly desperate tactics. The frontal formation attacks involved entire squadrons rolling inverted and pulling through to attack from head-on in mass. The pilots would fire all weapons simultaneously at maximum range, hoping to saturate the defensive fire and destroy the lead bomber. If successful, this could disrupt the entire formation. If unsuccessful, the Germans would lose multiple fighters to defensive fire. Some German units developed specialty tactics. Sturmgruppen, assault groups, flew heavily armored FW-190s equipped with additional armor and heavy weapons. These aircraft would close to point-blank range before firing, accepting defensive fire hits to ensure their own strikes were effective. The pilots of these units had casualty rates approaching 100% per month, but inflicted disproportionate damage on bomber formations. The most desperate tactic was ramming. Sonderkommando Elbe, organized in April 1945, consisted of volunteers who had taken oaths to destroy American bombers by any means necessary, including ramming, if ammunition was exhausted. On April 7, 1945, approximately 180 German fighters from this unit attacked bomber formations, with roughly 20 pilots deliberately ramming B-17s and B-24s after expending their ammunition. The tactic destroyed 17 American bombers, but cost the Luftwaffe 133 fighters and their pilots, an unsustainable exchange ratio that demonstrated Germany's desperation. The gunners defending the bombers faced impossible decisions in milliseconds. Fighters appeared suddenly at high speed. Gunners had to identify the target as enemy, estimate range and deflection, and begin firing before the fighter closed to effective cannon range. The .50 caliber guns had effective range of 1,000 yards, but hitting a fighter traveling at 400 miles per hour required leading the target by hundreds of feet. The gunners learned through experience, training that combined actual combat with extensive practice on training ranges. The top turret gunner, seated behind the pilots in a Sperry turret, had perhaps the best visibility and most important defensive position. He could engage fighters attacking from above and ahead, the most common approach angle in 1944. The turret rotated and elevated through electric motors, controlled by the gunner's hand grips, with a computing site that helped calculate lead angles. Good top turret gunners could track and engage fighters to route their attack runs, sometimes deterring attacks through accurate fire before the fighter could launch its own attack. The ball turret gunner, suspended below the aircraft in his Sperry ball, had unobstructed view of the lower hemisphere. The position was cramped, gunners needed to be small to fit, and terrifying. The gunner sat with his knees drawn up, controls in his hands, swiveling the entire sphere to track targets. If the aircraft was hit and needed to make emergency landing, the ball turret had to be rotated to allow the gunner to exit. If the hydraulics were damaged, the gunner was trapped. Multiple ball turret gunners died trapped in their turrets during emergency landings. The waist gunners, one on each side, manned .50 caliber guns in openings that exposed them to -50-degree slipstreams. The positions had no heating and minimal protection. Gunners wore heavy flight suits and gloves, but still suffered frostbite regularly. They stood for hours, watching for fighters, firing when targets appeared, trying to ignore the cold and the fear. The spent shell casings accumulated on the floor, becoming slippery hazards. Blood from wounded crew members froze almost instantly in the sub-zero temperatures. The tail gunner, isolated in the extreme rear of the aircraft, manned twin .50 caliber guns covering the rear quarter. The position was solitary and exposed. Fighters attacking from behind focused fire on the tail guns first. The tail gunner had communication with the crew only through intercom and was completely dependent on the aircraft remaining flyable. If the bomber broke up, the tail gunner's chance of escape was minimal. Many tail gunners flew entire tours, never seeing their crew members' faces except during briefings and debriefings. The bomb run itself was the most dangerous phase of every mission. The bombardier took control of the aircraft through the Norden bomb site, flying the bomber straight and level for 2 to 5 minutes while lining up on the target. During this time, the bomber could not evade flak or fighter attacks. The formation had to maintain precise course and altitude, while German gunners fired everything they had. This was when most bombers were lost, not to fighters, but to flak that found the stable, predictable targets. The moment of bomb release was marked by the aircraft suddenly surging upward, 4,000 to 8,000 pounds lighter. The bombardier would call, "Bombs away," and control would return to the pilot. The aircraft would bank away from the target, the formation reassembling for the return flight. Crew members would assess damage, treat wounded if necessary, and begin the long flight back to England. The return flight could be as dangerous as the penetration. Damaged aircraft struggled to maintain formation, making them targets for German fighters patrolling specifically for stragglers. Aircraft with damaged engines or control systems fought to stay with the formation, knowing that isolation meant almost certain destruction. Pilots nursed damaged aircraft across hundreds of miles of hostile territory, managing failing engines and battle damage, trying to reach the English Channel and the safety beyond. Many aircraft didn't make it. Damaged bombers fell behind formations and were picked off by prowling fighters. Aircraft with catastrophic damage went down over Germany, their crews bailing out to become prisoners of war if they survived. Some aircraft, too damaged to reach England, diverted to neutral Switzerland or Sweden, where crews would be interned but survive the war. Others ditched in the North Sea or English Channel, where air-sea rescue services struggled to recover crews before hypothermia killed them. The aircraft that did return often arrived severely damaged. Some crash-landed at emergency fields along the English coast, too damaged to reach their home bases. Others made gear-up landings when hydraulic damage prevented landing gear extension. Some landed with wounded or dead crew members aboard, with other crew members having applied first aid during the return flight. The ground crews who met returning aircraft often found them so damaged that they were shocked the bombers had flown at all. The maintenance required to keep B-17s flying was enormous. Each aircraft required approximately 200 man-hours of maintenance for every flight hour. Ground crews worked through the night repairing battle damage, replacing engines, patching holes, and preparing aircraft for the next mission. The crew chiefs, responsible for individual aircraft, took fierce pride in keeping their bombers flying despite the damage inflicted daily. The replacement system kept units operational despite losses. New aircraft arrived regularly from the United States, flown across the Atlantic by ferry pilots. Replacement crews arrived from training bases, eager and terrified, knowing their chances of survival were poor. These replacements filled out depleted units, maintaining operational strength even as losses mounted. The system was brutally efficient. Losses were replaced so quickly that bomber strength remained relatively constant despite appalling casualty rates. The industrial statistics behind this replacement system were staggering. American factories built 12,731 B-17s during the war. At peak production in 1944, factories completed 350 bombers per month, more than 10 per day. This production rate exceeded Germany's ability to replace losses even when German fighter production increased. For every German fighter that shot down a B-17, American factories built 2 more bombers. The mathematics of attrition favored America overwhelmingly. The B-17's operational record reflected this industrial superiority. From 1942 to 1945, B-17s flew approximately 290,000 combat sorties over Europe, dropping 640,000 tons of bombs. They destroyed approximately 16,000 German aircraft, 11,000 in aerial combat, and 5,000 on the ground. These losses crippled the Luftwaffe more decisively than any other factor. Germany couldn't replace experienced pilots fast enough, couldn't produce sufficient fuel, couldn't maintain operational readiness in the face of sustained attrition. The specific targets struck by B-17 formations had strategic impact that historians still debate. The aircraft industry was targeted repeatedly, forcing German production to disperse to smaller, less efficient facilities. The ball bearing industry at Schweinfurt was struck multiple times, though the impact on German production was less than hoped. Oil refineries and synthetic fuel plants were devastated in 1944, creating fuel shortages that grounded German fighters regardless of production numbers. Transportation networks were systematically destroyed, paralyzing movement of materials and troops. The mission to Schweinfurt on August 17, 1943, the same day referenced in this narrative's opening, illustrated both the effectiveness and cost of the bombing campaign. The 8th Air Force dispatched 376 bombers against ball bearing factories in Schweinfurt and Messerschmitt plants in Regensburg. The attacks succeeded in damaging critical facilities, but the Luftwaffe's furious defense destroyed 60 bombers and damaged 168 others. Over 600 American airmen were killed or captured. The losses were unsustainable. 1/6 of the attacking force destroyed in a single day. This mission precipitated the crisis that nearly ended daylight bombing. The losses were so severe that deep penetration raids were suspended until long-range escort fighters became available. The P-51 Mustang, entering service in late 1943, could escort B-17s to any target in Germany and fight on equal terms with German interceptors. The combination of B-17s and P-51s broke the Luftwaffe decisively during Big Week in February 1944, when concentrated attacks destroyed German fighter production and decimated the pilot force. The psychological impact on German defenders was profound. Luftwaffe pilot training deteriorated throughout 1943-1944 as experienced instructors were pulled to operational units to replace losses. New pilots entered combat with 100 to 150 flight hours compared to American pilots of 300 to 400 hours. The experience differential showed in combat effectiveness. Novice German pilots were easy prey for veteran American fighter pilots escorting the bombers. The ground crews keeping German fighters operational faced impossible challenges. Spare parts became scarce as transportation systems were bombed. Fuel quality deteriorated as refineries were destroyed. Airfields were cratered repeatedly, forcing operations from damaged runways or hastily prepared fields. The maintenance man-hours available per aircraft decreased steadily, reducing operational readiness rates. By late 1944, German fighter units could typically field only 25 to 30% of their nominal strength due to maintenance and supply problems. The civilian population in German cities learned to dread the sound of American bombers. The formations flew high enough that aircraft were barely visible, but the engine noise was unmistakable, a thundering roar from hundreds of Wright Cyclone engines that resonated for miles. Air raid sirens would wail and civilians would run for shelters, knowing that within minutes, thousands of bombs would begin falling. The psychological stress of repeated raids damaged civilian morale significantly. The accuracy of American bombing was variable. The Norden bomb site was theoretically capable of placing bombs within hundreds of feet of aim points from 25,000 feet, but actual combat conditions rarely allowed such precision. Cloud cover, smoke from fires, evasive maneuvers, and flak all degraded accuracy. Studies showed that only about 20% of bombs fell within 1,000 feet of aim points during typical missions. Yet, the sheer volume of bombs dropped ensured that targets were hit repeatedly until they were destroyed. The evolution of bombing tactics paralleled technological improvements. Early missions involved small formations attacking individual targets. By 1944, the 8th Air Force was dispatching 1,000-plus bomber formations against multiple targets simultaneously, overwhelming German defenses through sheer numbers. The formations included specialized Pathfinder aircraft equipped with radar for bombing through clouds, lead bombers with the most experienced bombardiers, and deputy lead aircraft to take over if leaders were shot down. The Strategic Bombing Survey conducted after the war attempted to assess the campaign's effectiveness. The conclusions were mixed. German war production actually increased through 1944 despite sustained bombing, though it would have increased more without the attacks. Critical shortages in specific materials, ball bearings, fuels, transportation capacity, created bottlenecks that hampered German war production. The Luftwaffe's destruction in defending against bombers removed air cover from other fronts, contributing to German defeats in Russia and France. The human cost of the strategic bombing campaign remains sobering. American bomber crews suffered approximately 26,000 killed and 28,000 captured. German civilians died in numbers estimated between 300,000 and 600,000 from Allied bombing. German military personnel, fighters, pilots, flak crews, and support staff lost approximately 160,000 killed. The ruins of German cities stood as testament to the destructive power that American industry could project across an ocean and a continent. The B-17 crews who survived their tours returned home as veterans of some of the war's most intense combat. Many suffered from what would later be recognized as post-traumatic stress disorder. They had nightmares about burning aircraft and dying friends. They startled at loud noises. They struggled to adjust to civilian life where people couldn't understand what they had experienced. The bond between crew members who had survived combat together was deeper than most peacetime relationships. These were men who had literally trusted their lives to each other daily for months. The aircraft themselves became symbols of American power and determination. The Memphis Belle's War Bond Tour in 1943 used the famous bomber to demonstrate that crews could survive the required 25 missions. The tours of damaged B-17s that had returned despite catastrophic damage showed American audiences what their aircraft and crews were enduring. The newsreel footage of bomber formations filling the sky became iconic imagery of American industrial might applied to warfare. German prisoners of war interrogated about the bombing campaign consistently expressed astonishment at the scale of American operations. Luftwaffe pilots who had fought on the Eastern Front described the Western Allied bomber streams as beyond anything they had experienced in Russia. The formations stretched for dozens of miles, with fighter escorts above, below, and alongside. The sheer number of aircraft visible simultaneously, hundreds at a time, demonstrated industrial capacity that Germany couldn't hope to match. Oberst Adolf Galland, commander of German fighter forces from 1941 to 1945, provided perhaps the most comprehensive German assessment in post-war interrogations. The American bombers, particularly the B-17, defeated us not through technological superiority in any single characteristic, but through systematic application of adequate technology in overwhelming numbers. Each B-17 was a compromise, slower than it could have been, carrying fewer bombs than its size suggested possible, consuming more fuel than optimal. But it was tough enough to survive, well defended enough to fight back, and produced in such numbers that we couldn't stop them all. We shot them down in hundreds, but thousands kept coming. That was America's way of war. Adequate solutions applied with unlimited resources. The technical evolution of the B-17 from the prototype Model 299 to the combat-proven G model reflected systematic incorporation of combat lessons. Each modification addressed specific vulnerabilities identified through combat experience. The chin turret eliminated frontal attacks effectiveness. The improved oxygen systems reduced crew losses from hypoxia. The better heating systems decreased frostbite casualties. The upgraded armor protected critical areas without adding excessive weight. The enhanced engines provided better high-altitude performance. Every change was validated through testing and implemented across the fleet. This iterative improvement process demonstrated American engineering philosophy. Rather than seeking perfect solutions, American designers implemented good enough solutions quickly, then refined them based on operational experience. The B-17G wasn't the optimal bomber by any theoretical standard. It was simply the bomber that worked best given the constraints of existing technology, production capacity, and combat requirements. German engineers, often pursuing theoretically superior solutions, were outpaced by American pragmatism. The bomber's legendary toughness wasn't accidental. Boeing engineers designed structural redundancy throughout the aircraft. The wing used multiple spars, so damage to one wouldn't cause catastrophic failure. The control systems had backup cables routed through different parts of the aircraft. The fuel system included self-sealing tanks that would close around bullet holes, preventing fuel loss and fire. The electrical system was divided into separate circuits, so damage to one wouldn't disable everything. Every system was designed assuming damage would occur and ensuring the aircraft could continue functioning despite it. The crew survival features were equally deliberate. The armor plating behind pilot seats could stop 20mm cannon shells from the rear. The bulletproof glass windscreen could withstand direct machine gun hits. The floor beneath pilots' feet was armored against ground fire. The self-sealing fuel tanks prevented the catastrophic fires that destroyed many aircraft. The oxygen system included emergency bailout bottles for use if the main system was damaged. Everything was designed to maximize crew survivability because trained crews were more valuable than the aircraft. This prioritization of crew survival over raw performance metrics represented a distinctly American design philosophy. German bombers, like the H-111 or Ju-88, were generally faster and more maneuverable than American bombers, but they were more vulnerable to damage and less survivable when hit. The German approach prioritized performance. The American approach prioritized survivability. In a war of attrition, survivability mattered more than speed. The training pipeline that produced B-17 crews was itself an industrial marvel. The Army Air Forces trained approximately 2 million personnel during the war, including roughly 193,000 pilots, 124,000 bombardiers, 50,000 navigators, and hundreds of thousands of gunners, radio operators, and flight engineers. The training bases scattered across the American South and Southwest operated on scales that dwarfed pre-war aviation entirely. Individual training bases had more aircraft than many nations' entire air forces. The training was comprehensive and demanding. Pilot candidates underwent primary, basic, and advanced training totaling 200 to 300 hours before earning their wings. They then received another 100 hours in multi-engine aircraft before being assigned to bombers. Bombardiers trained on Norden bombsights for months, practicing on bombing ranges until they could hit targets consistently. Navigators learned celestial navigation, dead reckoning, and radio navigation. Gunners fired thousands of practice rounds at towed targets and clay pigeons launched from aircraft. The crew formation process brought together pilots, co-pilots, navigators, bombardiers, engineers, radio operators, and gunners who had trained separately. These individuals had never worked together, but would depend on each other absolutely once in combat. The crew training phase welded them into cohesive teams through intensive practice missions that simulated combat conditions. By the time crews arrived in combat theaters, they functioned with efficiency that impressed even veteran instructors. This training investment represented massive resource allocation. Each B-17 pilot cost approximately $165,000 to train in 1944 dollars, equivalent to perhaps $2.8 million today. Each crew represented investment of roughly $1 million in training alone. The aircraft cost another $250,000. The crews received additional training in combat theaters before being considered ready for operations. The total investment in a single operational crew exceeded $1.5 million, an enormous sum that reflected how seriously America took the bombing campaign. The bases from which B-17s operated in England were themselves engineering achievements. The 8th Air Force operated from approximately 40 airfields scattered across East Anglia, each constructed to handle large numbers of heavy bombers. Runways were extended to 6,000 feet or more to accommodate heavily loaded aircraft. Hard stands for parking bombers were poured by the hundreds. Maintenance hangars, bomb storage facilities, fuel farms, and barracks were constructed on schedules that would be considered impossible by peacetime standards. The logistics of keeping bomber forces operational were staggering. Each B-17 consumed approximately 2,400 gallons of aviation fuel per mission. A typical mission involving 300 bombers required 720,000 gallons of fuel. The 8th Air Force flew missions almost daily when weather permitted, consuming millions of gallons monthly. All of this fuel was shipped from America in tankers that were themselves vulnerable to submarine attack. The fuel had to be distributed to bases, stored safely, and loaded into aircraft, all while maintaining quality control to prevent engine failures. The ammunition requirements were equally enormous. Each B-17 carried 3,000 to 4,000 rounds of .45 caliber ammunition per mission. A typical mission involving 300 bombers required approximately 1 million rounds per mission. The 8th Air Force fired tens of millions of rounds monthly. Each round had to be manufactured to precise specifications, packaged for transport, shipped across the Atlantic, distributed to bases, loaded into belts, and loaded into aircraft. The logistics chain supporting bomber operations extended from American factories through Atlantic convoys to English airfields. The bombs themselves represented massive production efforts. American factories produced over 5 million tons of aerial bombs during the war. The bombs ranged from 100-pound general-purpose bombs to 2,000-pound armor-piercing bombs designed for hardened targets. Each bomb required precise manufacturing. Improper fusing could cause premature detonation or failure to detonate. The bombs were shipped from American factories, transported to England, distributed to bomb dumps near airfields, prepared by armament crews, and loaded into aircraft. A single error in any step could result in catastrophic accidents. The ground crews who maintained the bombers worked with dedication that matched the flight crew's courage. Crew chiefs took personal responsibility for their aircraft, often naming them and maintaining them with obsessive attention to detail. These men worked through English winters in unheated hangars, repairing battle damage and performing routine maintenance under pressure to have aircraft ready for the next mission. They took pride in their work and grieved when aircraft they had maintained failed to return. The armament crews who loaded bombs and ammunition worked with materials that could explode if handled improperly. They loaded bombs into cramped bomb bays, connected fusing systems, and verified that everything was properly installed. They loaded thousands of rounds of ammunition into hundreds of belts, ensuring correct mixture of ammunition types and proper feeding. They performed this dangerous work repeatedly, knowing that errors could kill flight crews. The accident rate was remarkably low given the dangers involved. The intelligence officers who briefed crews provided critical information about targets, defenses, and tactics. These officers analyzed reconnaissance photos, interrogated returning crews, and compiled detailed intelligence assessments. They prepared maps showing flak concentrations, fighter bases, and terrain features. They described targets with precision needed for accurate bombing. They answered crews' questions about what to expect, trying to prepare them psychologically without causing panic about the dangers they would face. The medical personnel who treated wounded crew members faced challenging conditions. Aircraft returned with crew members suffering from gunshot wounds, shrapnel injuries, frostbite, burns, and psychological trauma. The medics provided first aid at flight lines, stabilized patients for transport to hospitals, and treated relatively minor injuries on the spot so crew members could return to duty. The flight surgeons who examined crews before missions tried to identify men too fatigued or stressed to fly safely while maintaining unit strength. Balancing crew health against operational requirements was a constant challenge. The combat experiences of individual crews illustrated the realities of bomber warfare better than aggregate statistics. Lieutenant Robert Morgan's crew, flying the Memphis Belle, completed 25 missions from November 1942 to May 1943, a period when loss rates exceeded 50%. Their survival was attributed to skill, careful maintenance, and considerable luck. Morgan's piloting was consistently described as exceptional, and his crew functioned with efficiency born of mutual trust. Yet they had numerous close calls, fighters attacking from all angles, flak that shook the aircraft violently, and mechanical problems that could have proved fatal with less skilled handling. Lieutenant John Lucky Doo's crew completed 25 missions flying with the 100th Bomb Group, known as the Bloody 100th because of its high loss rate. Lucky Doo watched most of his squadron die during his tour. Aircraft flying beside him were blown apart by flak or set ablaze by fighters. He saw parachutes streaming from dying bombers, knowing that some of those men would be friends captured or killed. He returned from missions physically and emotionally exhausted, wondering if the next mission would be his last. His survival, like Morgan's, combined skill with fortune that many equally skilled crews didn't share. The crew of Old Faithful, a B-17F that completed 100 missions despite being hit over 250 times by flak and fighter fire, became legendary for the aircraft's resilience. The bomber absorbed damage that should have destroyed it multiple times. On one mission, an 88mm flak shell passed through the fuselage without exploding. Had it detonated, the aircraft would have disintegrated. On another, a fighter's 20mm cannon shell severed hydraulic lines, causing landing gear to extend asymmetrically and requiring emergency landing procedures. The aircraft survived combat damage, mechanical failures, and accidents that destroyed other bombers. The crew attributed their survival to the B-17's toughness and their ground crew's skill, but they acknowledged the role of luck. The phenomenon of aircraft developing reputations was common. Some bombers were considered lucky. They sustained damage but always returned safely. Others were considered jinxed. They suffered mechanical problems and attracted enemy fire disproportionately. Crews assigned to jinxed aircraft were fatalistic about their survival prospects. The superstitions were irrational, but psychologically understandable. Men facing death daily sought any pattern that suggested some control over their fate, even when intellectually they knew that luck was random. The German defenses that B-17s faced daily were formidable and constantly evolving. The flak batteries ringing major cities and industrial targets were coordinated by radar and directed by predictive computers. The 88mm guns fired shells that burst at preset altitudes, creating lethal fragments over wide areas. The heavy flak could reach 30,000 feet and fire at rates exceeding 15 rounds per minute. Major targets were protected by hundreds of guns that could put thousands of shells into the air simultaneously, creating barrage fires that were nearly impossible to avoid. The fighter defenses evolved tactically throughout the war. Early German tactics involved individual fighters making multiple passes at bomber formations. This changed to Staffel, squadron, attacks, where multiple fighters attacked simultaneously from different angles to overwhelm defensive fire. Later innovations included frontal attacks by entire Geschwader, wings, where dozens of fighters would roll inverted and pull through to attack formations head-on. The tactics reflected German pilots' desperation as American defenses improved and German losses mounted. The specialized anti-bomber weapons developed by Germany demonstrated their recognition of the bomber threat. The Bf-110 and Me-410 heavy fighters were equipped with rockets and heavy cannons for standoff attacks. The Me-163 rocket-powered interceptor could climb to bomber altitude in minutes, but had very limited endurance. The Me-262 jet fighter was faster than any escort fighter, but required extensive runways and suffered from reliability problems. The FW-190 variants, equipped with additional armor and heavy weapons for close-range attacks, accepted defensive fire hits to ensure their own attacks were effective. Each innovation represented German attempts to find solutions to the B-17 problem. The German pilots themselves were professionals, fighting against overwhelming odds. Many were highly skilled aviators with extensive combat experience. They flew knowing that American numerical superiority meant they would likely be outnumbered in every engagement. They attacked despite knowing that defensive fire would destroy some of their formation on every mission. They continued flying as fuel became scarce, spare parts disappeared, and experienced leaders were killed. Their courage was undeniable, even as their cause was indefensible. The cost to these German pilots was severe. Luftwaffe fighter pilots on Western Front duty had life expectancy measured in weeks by 1944. Training barely kept pace with losses. Novice pilots entered combat with minimal preparation and were shot down quickly. The survivors gained experience, but faced mounting exhaustion as they flew mission after mission. The stress was compounded by knowledge that Germany was losing the war. They were dying to delay inevitable defeat rather than achieve victory. Post-war interviews with German pilots revealed complex attitudes toward the B-17. They respected the aircraft's toughness and the American crew's courage. They admired the disciplined formations and accurate defensive fire, but they also resented what the bombers represented: unlimited American industrial power crushing German resistance through material superiority. Some expressed bitterness that Germany had forced them to fight impossible battles against overwhelming force. Others accepted their defeat as consequence of attacking America and underestimating its capacity for industrial war. The strategic impact of the B-17 extended beyond physical destruction of targets. The bomber campaign forced Germany to divert resources from other fronts. The flak batteries defending German cities required hundreds of thousands of personnel and over 10,000 guns, resources unavailable for ground combat. The fighter aircraft defending against bombers couldn't support ground forces in Russia or France. The industrial capacity devoted to producing fighters and flak guns couldn't produce tanks or artillery. The opportunity costs were significant, even when bomb damage was repaired quickly. The psychological impact on German civilian morale is difficult to quantify, but was clearly significant. The constant bombing disrupted daily life, destroyed housing and infrastructure, and killed family members. The knowledge that American bombers could appear overhead anytime the weather was clear created persistent anxiety. The visible failure of German defenses to stop the bombers undermined confidence in Nazi leadership. The contrast between propaganda claims of German superiority and the reality of American air dominance was impossible to ignore. The final months of the war saw B-17 operations expand to virtually unopposed missions. German fighter strength had been destroyed through attrition. Fuel shortages grounded remaining aircraft. Experienced pilots were dead or captured. The bomber formations flew over Germany with minimal opposition, destroying transportation networks and finishing off industrial targets. The transition from desperate battles in 1943 to virtually free operations in 1945 illustrated the thoroughness of German defeat. The last B-17 combat mission in Europe was flown on April 25, 1945, against Pilsen, Czechoslovakia. By then, the outcome of the war was determined. German forces were collapsing on all fronts. The bombers that had fought through determined opposition for 3 years were now flying missions where the greatest danger was mid-air collision with other Allied aircraft crowding the skies. The crews who had survived years of combat were now counting days until the war ended and they could go home. The B-17s were retired rapidly after VE Day. The massive bomber fleet that had filled English skies disappeared within months. Some aircraft were scrapped in England to avoid shipping costs. Others were flown back to America and scrapped domestically. A few were preserved as war memorials or museum pieces. The combat veterans who had flown them returned to civilian lives, carrying memories of friends lost and battles fought. The ground crews who had maintained them returned to peacetime jobs, their wartime skills no longer needed. The legacy of the B-17 extended far beyond its combat service. The aircraft demonstrated that strategic bombing could achieve decisive results despite high costs. The lessons learned from B-17 operations informed post-war bomber design for decades. The training systems developed to produce bomber crews became models for military aviation training. The maintenance procedures and logistics systems pioneered to keep bombers flying influenced how subsequent aircraft would be supported. The industrial achievement represented by B-17 production remained impressive decades later. The ability to design, manufacture, and support 12,731 complex aircraft while simultaneously producing fighters, transports, trainers, and other military equipment demonstrated American industrial capacity that influenced Cold War strategic thinking. The Soviet Union and later other nations studied American wartime production as models for their own industrial planning. The human stories of B-17 crews became part of American military legend. Books, films, and documentaries told their stories to subsequent generations. The Memphis Belle became perhaps the most famous bomber in history. The crew's courage and sacrifice became emblematic of the American war effort. The aircraft itself became symbol of American determination and technological prowess. In the final analysis, German pilots' initial laughter at the flying tank was understandable but mistaken. They saw a large, slow bomber that appeared vulnerable to determined fighter attack. What they failed to understand was that the B-17 was designed from the beginning as a weapon system, not just an aircraft. It was designed to be manufactured in quantity, maintained in field conditions, defended by its crew, and survivable when damaged. It succeeded not through any single exceptional characteristic, but through systematic excellence in multiple areas. The bomber's defensive armament, structural redundancy, crew protection, high-altitude performance, and industrial production combined to create a weapon that Germany couldn't counter despite determined efforts. The Luftwaffe shot down thousands of B-17s, but couldn't stop the raids. For every bomber destroyed, American factories built replacements. For every crew lost, American training bases graduated replacements. The mathematics of attrition were inexorable. The transformation from laughingstock to nightmare took less than a year. By late 1943, German pilots approached B-17 formations with dread rather than confidence. The defensive fire was too intense, the casualties too severe, and the number of bombers too great. The battles became increasingly desperate as German fighter strength was ground down by sustained attrition. The pilots who had mocked the ungainly American bomber in 1942 were dead, captured, or too traumatized to laugh by 1944. Hauptmann Wilhelm Fischer, who had rolled into his attack dive over Schweinfurt in August 1943 with confidence and contempt, survived the war with permanent injuries. Post-war interviews found him bitter about the experience, but respectful of the aircraft that had destroyed his fighter and nearly killed him. "We were arrogant," he admitted decades later. "We thought our skill would overcome their numbers. We didn't understand that in industrial warfare, numbers and persistence defeat skill." The B-17 wasn't elegant or beautiful. It was tough, well-armed, and there were thousands of them. That was enough. The official statistics tell the story with clinical precision. The B-17s of the 8th Air Force flew 290,000 combat sorties, dropped 640,000 tons of bombs, and claimed 6,000 German aircraft destroyed. They suffered 4,750 aircraft lost in combat, approximately 1.6% per mission. Over 46,000 American airmen flew B-17 missions. 26,000 were killed and 28,000 became prisoners of war. The human cost was severe. The strategic impact was decisive. The industrial achievement was unprecedented. The aircraft that German pilots had laughed at became the weapon that helped destroy Nazi Germany. The flying tank proved impossible to kill, carried its crews through hell, and brought many home. Delivered bombs that shattered German industry and broke the Luftwaffe's back through sustained attrition. The laughter stopped early. The dying continued until Germany surrendered. The B-17 Flying Fortress had proven that sometimes the ungainly, heavily armed, tough solution was exactly what victory required. The Germans learned this lesson painfully, one burning fighter at a time, until there were no more fighters and no more pilots, and the sky belonged to America.